Okay, Bismillah ar-Rahman ar-Rahim. Let's discuss about Boolean algebra. So what is basically Boolean algebra doing here is that let's prove some theorems in a first. We gotta prove first theorem, that is a plus a is equal to a. That if you do the OR of the two, the same thing like a, that will be equal to a. Now to solve this, if we say proof, to prove this we say a is equal to a or 0, because we know if we do a or 0 it's gonna be a. This is what is called as by identity law. Okay, now we can also do the thing that we say this is a, and for this 0 we can say this is a and a complement, because a and a complement will always be equal to 0. So what we call as using complement law. Okay, now what we do is we use the distributive law. That means we say that if we say a or a, and this is a or a complement, so what I am doing is I'm distributing this a over these two guys. So first I say a or a, multiply it a with this guy, then and, right, then multiply this a with a complement, do ORing, in between we have an and. So basically we have this stuff, right? I'm putting a into this, then I'm putting a into a complement. Very simple. Now this is by distributive, using distributive law. Now here what we do is we say this is called a or a, and a or a complement. What is a or a complement equal to? That's 1. And again we can say using complement law here, using complement law, and now anything added with 1 is equal to that thing. If we have say a and 1, if we have say for example a and 1, it will be equal to a. If a is 0, it will be 0. If a is 1, it will be 1. So what will be output here? That is a or a. And now we got our solution, that a, here it goes a, is equal to a or a. That is what we had. So this is proved, right? So similarly we got the next thing. Similarly we have the next theorem, that is a and a is equal to a. That if you do a and a, that will be equal to a, right? A or a is equal to a and a is also equal to a. So we need to prove it. So we will say a and a, which is equal to, basically LHS, we take LHS, and this is a and a or 0, because it doesn't have any effect, because if you OR it with 0 it will be same a and a, right? Again by identity law. Now then I will say is equal to a and a plus, what can you write in place of 0? Yes, a and a complement, because they will be equal to 0. Now again by distributive law, right, because I say this is already distributed, let me condense it. So I will say a, I will get a common, and what will here remains? A, or what will here remains? A complement, because a gets common. Okay, it's again by distributive, by reverse distributive law I can say that, because if I distribute this, I have to say a and a, it will get back this, then I say a or, then or will be here, that the a and a complement, this will be this, so we'll get it back. Okay, good. So then we will say a or a complement is equal to 1. So I say a and 1. And what is a and 1 equal to? That is a. Getting me? So let's do the next theorem quickly. That is a or 1 is equal to 1. Right? What is a or 1 equal to? Can I write it like a or a complement? Because a or a complement will always be 1. Right? So instead of 1, I'm writing a or a complement. Getting me? Now using associative law, this is, we can say it by what else? Complement law, because a or a complement is equal to 1. Now I can say using associative law that I can say a or a complement. So combine them together and say a complement here, because it's associative. Because if you OR these two guys together, or you OR these two guys together and then this, because this was basically like this, because from the one we got it, from this one we got this thing. Now I associate these two and a. Right? What is a or a equal to? That is equal to a or a complement. So how we get it? It's called idempotent law. By idempotent law, we already discussed these things in our discrete digital electronics. Idempotent means if you have a or a, that is equal to a, right? And what is a or a complement equal to? That is equal to 1. So we got it back. So we got right hand side. So hence proved. So the next theorem will be like this: a or a and b is equal to a. Right? Okay. So this is my theorem and this is my proof. What I will do is I will say a or a and b is equal to a by identity law. I will say a and 1, okay, or a and b. This will be by identity law. But I'm saying a or a and b. From instead of a, I'm saying a and 1. Okay, getting me? So by distributing, what I'm gonna say is I will say a and 1 or b. So I will get a common here, 1 will remain here, b will remain here, because a is common. Getting me? So what is 1 or b equal to? 1 or b, that is always b equal to 1, right? And what is a and 1 equal to? Identity law, again identity law, that will be equal to a. So we got the RHS. You getting me? Now let us discuss few which have come in the exam, which comes in the exam regularly. That is like this: a and a or b is equal to a. You have to prove that. So we say proof, okay, taking LHS. Let's take LHS. Let's say a and a or b, right? Now we will say by distributive law, what will this be equal to? A and a, right? Yes, can you tell me? A and a, what should be? Should here be or and? Because this is a and a, multiply and with this, then this or remains here, then this a and will be multiplied with this, so this is a and b. A and a plus a and b by distributive law, right? Which says that you distribute a over these things, that product is distributed over sum, right? Good. Now what is a and a equal to? Now you have to tell me, because I think we have done it. What is a and a equal to? If you add a with a, that's gonna be what? That's gonna be a, right? Again, what we call it as idempotent law. Just here we discussed it. Idempotent law, because a or a is equal to a. Similarly, a and a is equal to a, right? Okay, so there is a plus in between. Then we have the A and B. Okay, so we got A or A and B. So can I write it like I can write it like A and 1, okay, or A and B, because A and 1 is again A. Whatever the A will be, that will be the answer here, because and with 1 means whatever A will be, the answer will be A. So instead of A, I can write A and 1 plus A and B. Right, getting me? So if I now get A as a common, if I get now A as a common, okay, what will be inside of this will be 1. What will remain here, because A is common? We got A1 or B, because what I want to do is I want to cut off this B, because I have on the right side only A. So that means I have to cut this B somehow, right? So that's why I am doing this thing. First, what we did is we distributed A over these things, right? And then what I'm telling is I'm getting a 1 here, okay, because I want this 1 to be with the B, like this, 1 to be with the B, so that I can cancel out B. So what I did is A and 1, and this is same. Now A gets common here, so 1 remains out of it. A gets common here, I have got it here, so no need to write. So B gets here. What is 1 or B equaled? Can anybody tell what's 1 or B equaled? That's equal to 1, because if you 1 or with B, that is 1, right? If you 1 or with A, and with A, that is A. But if it is 1 or with A, that is gonna be 1 always. If it is a 1 and with A, it is gonna be A, because if A is 0, it will be 0. If A is 1, it is 1. Here, if it's A is 0 or 1, immaterial, because if you OR with 1, always it will be 1. Getting me? So 1 OR with B is 1. And what is 1 and with A? We have already done it. That is A. And this is our RHS. LHS is equal to RHS, right? Hence proved. Let's do a few more, because these come in exam. You have to understand that these questions will come in exam. So let's do second question, which is saying A or A and B is equal to A. Okay, A or A and B is equal to A. Now again, this is my theorem, this is my proof. In the proof, I should taking LHS, right? So what is that? A plus A and B implies, because I want A out of it, that means I have to somehow remove this B, isn't it? So isn't it the half of that question? A or A and B? Isn't it this question? It is from here. Okay, you have to understand that. So what should I do? I will put a 1 here, because I will say that like this. I will say this is A and 1, because A and 1 is equal to A plus A and B. Now out of it I will get the A out. What will be here? 1 or B, right? So what I did is I said only 1 here, right? Then A into 1 or B. So what is A into 1 or B equaled? That is A and 1. What is A and 1 equaled? That is equal to A. Give reasons what I have given on the above parts. Give those reasons here. Okay, how we can get it. You got it or not? So we got it. So let's do the next theorem, which is saying A plus A complement, A plus A complement and B is equal to A or B. So here we got the proof, and what we say proof is this question is very important because they come in exams, so you better grasp them completely, just learn them. So taking RHS, here I will do what? Taking RHS, right hand side, that is A or B, right? And I can say A or B is equal like this. I can say this is equal to A or B and 1, because if you add with 1, right, because I have to somehow get this A complement somewhere, right? This is my problem. If it would have been A or A and B, this would have been very easy, because I would have introduced it here 1, the previous question like this, A or A and B, I would have introduced it 1 and just for 1 we did it, we could have done it easily, but here we have A complement, so we have to do a little bit here. So I'm putting in on the right hand side A or B, then I say A or B and 1, because if you add with 1 with this thing, it will be A or B. That is right. Okay, I can say again A or B, but instead of 1 here, I can say here in terms of A, because I want to bring the complement into the picture. So I can say here A or A complement, because A or A complement, if you do A or A complement, it's always be 1. So if you OR with something, if it is 0, for example, A complement will be 1. 0 and 1 is 1. If A is, for example, 1, A complement is 0. 1 plus 0 is 1. So that's always 1. So instead of 1, we can write A or A complement. So I got my A complement now. Now I got to do little work to get it back my left hand side. You getting me what I'm doing? Okay. Now what we do is we multiply this A or B into A and also into this A complement. So this will be equal to A or B, right? And A. I'm multiplying this A or B with the A, plus by distributive law again A or B into this A complement. Getting me? Very simple. I have done this whole thing A or B, multiplied with the first this A, then multiplied with the A complement, and or remains in between. Right? Good. So far good, I think. So I got the A or B and A plus A or B and A complement, right? Okay. Now I can distribute the same thing to this thing. I can multiply this A with the A, this A with the B. So I can get A and A plus A and B, multiplying A with the A, okay, and multiplying A with the B, then plus, now the same thing here, this will be A and A complement plus A complement and B, is it? Multiplying this A complement with this, multiplying A complement with B. Good. Now I think it will be now easy for you guys, because now what is A and A? That will be A plus A or B, that will be like that, plus what is gonna be A and A complement. So it is and in between. If you complement A complement and with A, that is always be equal to 0 plus A complement and B, right? Getting me or not? Okay. If among these two guys, if among here, I will do what? I will get the A as a common. Okay, if I get A as a common, or I can first say A or A and B, because A and B are with 0, that will be A and B, right? Because if you have something like 1, you or with 0, this will be equal to 1, or if it is 0, you or with 0, it will be 0. So whatever here we have, it will be that thing. So instead of 1, I am having A and B. If I am doing it or with 0, it will be A and B. So I can remove this 0, because A or B or 0, A and B or 0 will be A and B always, plus A complement and B. Now what I will do here is, because I have to see my left hand side, what I have to prove, right? I have to prove this thing, A or A complement and B. So I need here on one side I need A, and on the next part I need A complement and B, right? A complement and B I already got it, so इसके साथ मैं नहीं छेड़ूंगा क्योंकि मुझको मिल गया. अब इसमें से मुझे निकालना क्या है? A, right? So let me do one thing. I will get the A as a common. So what will be A as a common? So what will remain here? This will remain here what? 1, because A this will be 1 only, because this is basically a and with 1. Okay, this is basically a and with 1. We don't write it, but it is there. So 1 will be there, plus from this a is getting common, so 1 plus b. This thing we have already done. This part we have already done to get a out of it. Okay, so 1 plus b is equal to 1. So this will be a and 1 plus a complement and b, and a and 1 is definitely equal to a plus a complement and b, and this is my LHS. So sorry, RHS. So RHS is equal to LHS. So hence proved. Quod erat demonstrandum means hence proved. You getting me? The next thing will be conditional and biconditional statements, which comes in exam, and also the truth table formation. That is very simple. Yeah, you can do it easily. But before that, I would like to give you some notations. Like if we have some sets notations, then we got the statements, and we got the Boolean Algebra. Like we say A union B. Like this is written as OR statement in case of statement P or Q, or in case of Boolean algebra we say plus sign. Similarly, if it is A and B, intersection B, it is basically P and Q. So this is basically A and B, right? These are some statements, you know them already, but we need them. P complement, so here we say A complement, like that. You can see that from any book, it's very easy, and we already know that actually A subset of B, right? We say P implies to Q here, and here we say not P or Q. This is important to say, it's not P or Q, okay? Or we say P complement or Q. Okay, similarly, we've got a universal set on this side. This is true, we say this is equal to 1. If we got the null set, we say this is false in a statement, and we say 0 in case of the Boolean algebra. Are you getting me? Okay, similarly, if I got some equations here, that is A union A complement, that is definitely equals to the universal set. So in this case we say P, because the union means or, P complement, that's always could be true. In case of Boolean algebra, we say A or A complement is equal to 1, right? Because or is equivalent to this or is equal to the plus, and here we got the union for that. And for universal set we have true, and in Boolean algebra we have 1. Simply, if it's A intersection A complement, that's gonna be phi null, I actually null set. And similarly, we've got P and P complement is gonna be false, right? And A complement gonna be 0. Similarly, A union A is equal to A. P or P is equal to P in case of, and A or A is equal to A. The last thing what we're going to do here is about A intersection A is equal to A, right? Similarly, P or and P is going to be P, and A is going to be A, right? So with this, this was a little bit about the notations, and now we go to the conditional and biconditional statements, which comes in exam. That what is conditional? The question will be asked like conditional. What is conditional biconditional statements, and explain with an example like that. So we have to understand what is a conditional and biconditional statement. So before that, let's first discuss what is a preposition. Okay. So what is a preposition? Okay. Basically, this is a chapter from logic and propositional calculus, and we need to do this because we have one or two questions which comes from this, so better we discuss them in a proper way. So what is a preposition? If we say what is a preposition, so a preposition is a statement. Basically, a preposition is a statement. So I say a preposition, or a statement or statement, because we have a preposition or we have a statement. It's a declarative sentence. Is a declarative sentence which is either, it's a definition of it, which is either true or false. Okay, basically these are true or false, but not both. Getting me? For example, we have example. We say, for example, something like 2 plus 2 is equal 4, right? Or we say this is the true statement. We could have the false statement, like we say 2 plus 2 is equal to 9. This is the false statement. Similarly, we have a statement like Junaid is our teacher. Okay, this is again a statement which tells us something which is true or a false, right? This is the main important thing, is that it should be a preposition to something which is true or false. Now what we do is we represent, the simple statements or prepositions by some some letters, like we have the P and Q, like we say P, we use these letters P, Q, R, etc. These are called as preposition variables. So we need these to represent them in some mathematical terms, because we cannot use the English sentences like that. Okay, then they could be true or false, so represented by T or F, T and F, true or false. We could also the composite, composite prepositions or compound prepositions, which are made up of many prepositions. Okay, like I'm saying, like we say like this: Noreen is intelligent, okay, or studies harder. Either she is intelligent, or studies harder. So if you could see, now we have some ors and ands coming into these statements, but this is not a simple one. This is a compound preposition. This is a compound preposition, because you could understand this, because as you could see, we have combined the prepositions here, the statements here, using a connective or. So therefore we need to connect these guys together. The prepositions are to be connected by the connectives, right? We call them as connectives. You already know all these things, but just with a different, the different clothing it is. So we have a lot of connectives, like we have and, we have or. Okay, if you have negation, if you have the negation, for example, we show it like this. I have already shown the notations. We show it like this: a tilde sign with the P. This shows negation of a P. Okay, sometimes we use symbols like this in a discrete mathematics or something like that. Okay, or you can use this one with a tilde. And we have the or that goes down. Okay, is it or and? This is and this is my or statement. Okay, and we sometimes call it a conjunction and disjunction. So for example, we say P and Q, this is called as conjunction. And if we have P or Q, this is called as disjunction. You got me? And sometimes we have the implications or conditional. That is called, we have implicational condition, like we have this thing. Or sometimes also single arrow. This is if something then something, okay, which implies you something. So this is called as implication. Okay, or sometimes a conditional. This is a conditional. What is called as a conditional, that which is giving some condition. If something, some condition, then it should be something like that. So what we can show is like this: P implies to Q, that is if P then Q. right? And we show it, I have already shown it. This is P and not Q. Okay, P and not Q. This is shown like this equivalent. You getting what I'm saying? Okay, similarly, if we have a biconditional, the symbol for the biconditional definitely will be on an arrow on the both sides. So this means if and only if. So if and only if, this is called as equivalence, or we say it as biconditional. This is what question comes. What is the difference between conditional and biconditional? We'll do a bit here. Biconditional. So like we say P, double implies Q. Okay, this is called as biconditional, means if and only if. Okay, we'll give examples of these. So let me give the definition of because I have seen the question about the what is the biconditional questions. What is the biconditional statements? So we say the definition of it is if P and Q are statements. Okay, or a statement, then we say then the compound statement P if and only if Q, denoted by P, double implies Q, is called a biconditional statement, and the connective if and only if, and the connective if and only if is called the biconditional connective. Is called the biconditional connective. It's the biconditional connective. Okay, for example, I teach you if and only if you are in your first year student, or you are something like first year student. So if you are second year or third student, I'm not going to teach you. So this is something. Or I can say price of, or I can say prices of goods increase, or we say decrease also. Price of goods increase if and only if price on petrol increases. So now these are our biconditional statements, right? Okay, now the next thing is to make a truth table out of them. So a truth table is which comes in regularly for exam. So that's very simple. For example, let's start with the simpler one. Let's start with the simpler one. Like we have P and this is the Q. Okay, and then there is a P and Q. Okay, now we'll make a conjunction, disjunction, and also the negation. So how you write it, this is same as what you have done in the digital electronics. The only thing is we don't write here 0001. You write here for true, then true false, then you can say false true and false false, right? So P and Q, or you could have gone from false false to this, because 0001 like that. Okay, that's your choice. And what is going to be P and Q? If you're going to P and Q, true and true will be true, and rest will be false, right? Or if you want to do the disjunction of the same thing, true true, true false, then false true, and false false. And how you gonna make it here if it is P or Q? So this will be true, this will be true, this will be true, and this will be false, right? Very simple. And if we have the negation, okay, if we have a negation like P and we got a P complement, how we going to do that is very simple. That if it is true, it's going to be false. If it is false, it's going to be true. So let's do now a little bit complicated, which comes in exam. Now we have, say for example, some compound prepositions, okay, and we want to make the truth table out of that. Like we have P and Q complement or Q. Okay, now this is our complicated one. So what I will do is, first, because I have P and Q only, so I will make the P and Q out of it first. And what combinations I will have? True true, true false, false true, and false false. After that I will do the negation of Q. Okay, so if you do negation Q, this becomes false true, false true, right? And I can do now the negation of Q. Okay, I can do multiple ways. I can do with the negation Q. I have done negation Q. I can do it the OR with the Q. Okay, then I have to do with the AND with the P. So what I should do is negation Q or Q, right? Now do OR of these two guys. So simply it is true false is true, this is gonna be true, this is gonna be true, so everything will be true, all true. Now do because we have calculated this thing, right? Now iska AND karna hai P ke saath. Now we say P and negation Q or Q, right? अब ये हम निकालेंगे यहाँ पे, यानी कि इस चीज़ का हम P के साथ, P हमारा ये है, P के साथ हम क्या करेंगे? And this is very simple. इस P के साथ जो हमारा P है यहाँ पर, इसके साथ हमें इसका AND करना है इस चीज़ का. Okay, very simple, right? So when you do the AND, what will come the answer? So true true पहले दोनों है तो true ही होगा, दूसरा भी true true है, true ही होगा, तो फिर दो false होंगे हमारे पास, true to false false. Getting me? Okay. Similarly, we could have another one. Let's make another one. Another question which says that the question is like this: P or Q or negation of P and negation of Q. One thing here, that this is not negation of P. First you have to do P or Q, then overall you have to do negation. That's important here. And this will be your home task. Just start doing it. I will give you the last answer, which comes, the answer of this thing, which comes is, that is false, false, and false and true. This comes the answer. You check it out. Okay, start doing. Pause the video and start doing this. The next thing what we do is here is about the tautologies and contradictions. छोटा सवाल आता है इसके ऊपर, एंड इसमें ट्रूथ टेबल भी आ सकता है इसके ऊपर सवाल. इट्स वेरी सिंपल कि अगर आपके जैसे यहाँ पे हमें, अगर आप देखोगे इन बिटवीन इसमें सारे ट्रू आए थे, मान लीजिए यही हमारा एंड प्रोडक्ट है, एंड हमारा इसमें तो हालांकि ये था, मान लीजिए हमें ये निकालना होता, खाली ये नहीं करना होता, तो इसमें जो है सारे ट्रू है. सो अगर आपके सारे ट्रू आ रहे हैं एट द एंड, दिस इज़ योर टोटोलॉजी. और अगर आपके पास यहाँ सारे फॉल्स आ रहे हैं, तो दैट विल बी योर कॉन्ट्रडिक्शन. ओके, so what will be the definition of this? definition of the tautology and contradiction. So we say a compound preposition, because basically this is about the compound preposition. A compound preposition that is always true for all possible truth values. The truth value here doesn't mean the true values, it's a truth table values, okay? Means all the combinations of its variables. You have to remember this definition because the question comes about its definition. So that's why I'm writing here definition. Or you can see any book, or in other words contains only T, means truth, okay, in the last column, in the last column of its truth table. Is called what? Yes, is called what? Tautology. So tautology is something which has the T in the last column, right? So remember that. So you write in a same way a compound preposition that is always false if we have not true but the false. If we now have false for all possible truth values of its variables, in other words contains only if, false in the last column of its truth table, is called here contradiction. So if you do not have a which is a mixed response, like which is not a tautology, not a contradiction, because contradiction means you should have in the last column all the falses, right? In a tautology you should have all the true, but if you have mix up, what is that called? That's called as contingency, which is neither tautology nor contradiction. If you have a compound proposition which is neither tautology nor a contradiction, then it is a contingency, right? Now if the question comes like it doesn't come, the question usually comes about what is tautology, okay? And if the question comes like that you have to prove the following prepositions as tautologies, like P or negation Q, to prove is it tautology or not. So what I do is we will make a truth table out of it. This is P, this will be true or false. What is the negation of P equaled? That is false and true. And if we do P or negation of P, that means or these two, that is gonna true and true. So this is a tautology because the last expression is true. So similarly, if anything comes in, you just make a truth table and see what is in the last column. If the last column is all true, it is a tautology. If it isn't, it is not. Or similar way, if it is all false, it is a contradiction. Otherwise, what it is? It is otherwise a contingency. Now let's make a truth table of conditional and biconditional statements. So if we have like this, okay, so if we have a conditional statement, then P and Q we got, for example, this is true, 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 false, false, true, and false, false, right? It's like this. So what we say is P implies to Q. How we get it? How we get the P implies to Q? I said this is equal to what is the definition of P implies to Q? As I said that P implies to Q is logically equal to not P or Q. Okay, not P or Q. So if you want to find P implies to Q, you just find the not P or Q. So if I do it here, like this is P and Q, and this is my P, that is true, 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 false, false, true, and false, false. Now what we do is we say not P. What is not P gonna be? That's gonna be false, false, true, true. And with the Q now, you got not P, you got the Q, just order them together just to get this thing. Okay, so this will be true, this will be false, this will be true, and this will be true, is it? So this will be true, false, true, true. Okay, that is equal to P implies to Q. So if you want to say here, this is true, false, true, true. Okay, and the second thing is, so if you want to find P implies to Q, that means conditional statement, then just find out actually this thing. You got to find out this thing because logically equivalent to this. And second is, if you got a biconditional statement, if and only if, why do we say if and only if? So that is P and Q, that is basically equal to equivalence. I'm saying biconditional statement, biconditional statement. If you want to find biconditional statement of these, this is true, 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 false, false, true, false, false. So if you want to find P biconditional statement to the Q, biconditional of Q, what will be that? Okay, that's equal to equivalence. Have you read in digital electronics equivalence? That is the complement of XOR. Okay, that is the same thing here. For example, you have in the equivalence, what do you say in the equivalence? We say when the both it will be what will be the XOR first? What XOR means that it will be 1 1 here and 0 0 here. What is the complement of XOR? That means 1 will be here, 0 0 1. This is the equivalence, right? What we basically say, like, it is P complement Q, okay, or PQ complement, right? Like this. So you find this P complement Q or PQ complement. Is it? This is XOR. Then you have to complement it together. So in that case, we will get is P complement Q complement, right? Or PQ. This is what is called the equivalence. So this is logical equivalent of biconditional statement. So complement both of these guys, PQ, and don't complement PQ. That's it. Or you can say 1 here, 0 0 1. So I should not say 1, I should say false here. Sorry, I should say here true, false, false, true. This is my biconditional statement truth table. Is it? You getting me? Fine. Because I have, when the both are false, it is true. When the both are true, it is true. And when there is indifference, it's false. Okay, ulta hai na ye XOR ka. This is equivalent to equivalence. Are you getting me or not? Good. So next thing what we discuss here is what is an argument. What is an argument? Okay. So argument, if it defines the argument is an assertion by virtue of which you will get some prepositions. Like you will get some preposition P1, P2 and so on. Okay, those prepositions are called premises. Like you have P1, P2, P3. These are your prepositions which you get from some assertion. You say something and you get out of it P1, P2, P3, what you called as premises. These are called premises, these prepositions which you yield as a consequence. You know, ये आपके नतीजे पे आपका ये जो आप काम कर रहे हो उसके नतीजे पे आपको कुछ prepositions निकल रहे हैं, उनको हम premises बोलते हैं, और जिनसे आपको निकलता है उसे कहते हैं हम argument. ओके, और एक और चीज़ होता है इसमें जिसे कहते हैं हम कंक्लूजन, यानी कि इन सब से फिर एक आपका लास्ट में जो निकलेगा कंक्लूजन, दैट्स कॉल्ड एज ए क्यू. ठीक है, सो एक डेफिनेशन यहाँ पे लेते हैं जो कि हमें इंपॉर्टेंट है एग्जामिनेशन पॉइंट ऑफ व्यू, जो कि टॉटोलॉजी के साथ हमारा एक सवाल आता है फैलासीज का. ठीक है, तो हम कहते हैं कि डेफिनेशन देंगे यहाँ पे एन आर्गुमेंट. आर्गुमेंट आप समझ चुके हो, P1, P2 dash P of n, इसका conclusion Q है. This will be the argument because we are getting out of that argument P1, P2, Pn. That is basically the combination of these prepositions, and a conclusion is your argument. इसको हम बोलेंगे वैलिड इज सेड टू बी वैलिड, इज सेड टू बी वैलिड, ये वैलिड है इफ जो आपका क्यू है, कंक्लूजन जो है वो ट्रू आ रहा है आपका। कंक्लूजन इज ट्रू जब आपके सारे प्रेमिसेस, व्हाट आर प्रेमिसेस, दीज प्रीपोजिशंस, ओके, इज ट्रू whenever all the premises कौन कौन है आपके पास, P1 P2 P of n dash dash और ट्रू, जबकि ये ट्रू है। और अगर आपके पास ये, तो ये हो गया वैलिड, दिस इज अ वैलिड आर्गुमेंट, ओके। और जो आर्गुमेंट आपका वैलिड नहीं होगा, सो दैट इज कॉल्ड एज अ फैलेसी। सो हम कहेंगे एन आर्गुमेंट which is not valid is called a fallacy, ठीक है। Now if we see on the top as an example of the premises, if you look at, these are our premises P and Q here, this is the premises of an argument, and the last one is not the premises, it's called the conclusion, okay. This is our conclusion, and these two guys are the premises, okay. And we are seeing that if, so conclusion, this argument is valid only if we have if our for example here we got a P and Q, the premises, they are true. It is only one case where they are true, is here true, and against that their conclusion should also be true, and we are saying yeah, it is. So this is a valid argument. So if you have the combinations of all the premises, you could have a lot of premises here, you can a lot of variables, you can understand that out of them, if there if we have the true conditions where they are all true, and P is Q, or there are other variables, they are all true, and against them their conclusion should also be true, then that a whole argument is valid. If it is not, then it is not a valid argument, right? So if it's not a valid, what else then it is a fallacy. You getting me or not? So what you do is you just check out all the premises if they are all, where they are all true. You have to see where are they all true. You can make a truth table of the statements you are given, making the premises out there, and you see, get the conclusion out there, and then see if we have a situation where all premises are true. Against that we should have the conclusion as a true. If it is not, it is a fallacy. Now this little bit I will tell you more about it. This is double implies actually. Let me go to the single implies. Okay, this is my single implies too, and I will say that I have to prove that is it a fallacy or a valid. It depends upon which are premises. So sometimes the question says that we don't necessarily have that P and Q as premises and P implies to Q as a conclusion. Sometimes it says like this: P comma P implies to Q, then conclusion is Q. Now my Q is conclusion, this P implies to Q and P, they are the premises, right? So I have to say, is this now valid or not? Because P and P implies to Q is premises. So what is the location where both of these guys are true? So I'm seeing this is a true and P is true here, and other than that P is true here, but here is false. I should not care about this. True and false here, don't care about this, because both of the premises, whatever the premises we have, they should be all true. यहाँ पे मुझे सिर्फ एक सिचुएशन आती है जहाँ दोनों ट्रू हैं, रो 1। क्या उस वक्त हमारा कंक्लूजन Q, क्या वो ट्रू है? हाँ है। सो दिस इज़ ए वैलिड। अगर इसके बगैर हमारे पास इसने ऐसे दिया होता कि वी हैव P implies to Q comma Q. Now my premises are P implies to Q and Q, okay, not the P and P implies to Q, बल्कि P implies to Q यानी कि ये और Q, ये दो मेरे premises हैं, और मेरा जो है what is called as a P is my conclusion. So क्या इस सूरत में ये valid है या ये fallacy है? ठीक है? So now you can give this example and in support of your definition of fallacy, right? And valid argument or fallacy. Are you getting me? Now what happens here is we are saying P implies to Q and Q. अब P implies to Q और Q अगर इसमें देखा जाएगा P implies to Q और Q तो ये है, ठीक है, पहली स्टेटमेंट है। हाँ उस वक्त P जो हमारा ट्रू है, गुड, लेकिन अगर यहाँ देखेंगे यहाँ पर भी ये दोनों ट्रू है, ठीक है। अब P implies to Q और Q जो हमारे प्रीमिसेस वक्त हैं, P implies to Q है और Q है, और यहाँ पर भी वो ट्रू है दोनों। क्या उस सूरत में हमारा कंक्लूजन P क्या वो ट्रू है? नहीं है, वो फॉल्स है। सो इट इज़ ए फैलासी, इट इज़ नॉट ए valid argument, it is a fallacy. You getting me? Okay, so that's it. Yeah.